Hello, everybody. I was just confirming that the recording started. I didn't get my little red dot, but it does say it's recording. So this is our sprint demo for the Evernym team that works on contributing to the sovereign ecosystem and the Indy project at Hyperledger. And it's February 28th, and this is our fourth sprint in 2019. We've done a chunk of work, and we're excited to share it with everybody. It's interesting that on the mostly Indy SDK team, a good part of the Indy SDK team was attending the Sovereign Connectathon last week. It took up half the sprint, and that was a really useful exercise at the Sovereign Foundation. There were a lot of contributors to the project from all over the world, actually, came and shared what they've been working on. We were talking as a team about how our favorite part was seeing the demos of all the agents that people have built using the Indy SDK to talk to most of them were sovereign agents. And the list is pretty cool to look at the list. Luxoft in British Columbia and StreetCred and Spark in New Zealand. Veridium demoed their usage for biometric credentials, fingerprinting. IBM did a demo. It was a really neat event to see everybody doing stuff. Of course, Evernym demoed our stuff, and Pico Labs at Brigham Young University. So it was a very successful event, and if you're interested, I expect a lot of these demos will move into the Indy working group calls. That's Thursday morning Utah time. It's Thursdays. You can see it on the Hyperledger community calendar when those calls are. But if you join, you'll probably get to see a lot of these as they continue to progress. As for the Evernym team, because we spent a chunk of time there, our sprint was a bit chaotic on the SDK side. We took in a lot of community bugs and a lot of community collaboration items and got those done. But we also had to rethink our architecture of the SDK to respond to the feedback we received at the Agent Connectathon. And you're going to see how that feeds into our future sprints as we document this improved architecture and share it for feedback. The main task was that we got a lot of feedback on the credential exchange hype, the Hyperledger Indy project enhancement. We documented the credential exchange message family, and if anybody seeing this video has feedback on that message family, please put it in. We need to get that accepted in the next couple of weeks so that we can formalize it and move it into our applications. But there's a number of items that we still need to review and validate to move them in the next sprint. We will have a demo on the error handling improvements, which is probably the most substantive piece of this sprint. On the Indy Node side, after all the chaos we had last fall, trying to decide how to structure a node for the long term, we're finally completing all that work we laid out. So the Audit Ledger is nearing completion. We're going to talk about that quite a bit more. And the multi-signature support and moving permission handling to the config ledger is nearing completion, and we're excited to talk about that. So that's what we'll be doing today. And over the next couple of months, we'll get those released, and we'll continue working on improvements to the Ledger plugins so we can support the various plugins people want to add to the Ledger, specifically payment plugins that people want to add. So that's the overview of the sprint, and let's go into the demos. So I'll stop sharing my screen. Artem is going to take us through the improvements to the Vcx Error Handling.
Hello, everyone. My demo is about error handling improvements. Our team was concentrated on enhancement error handling. Actually, a couple demos ago, we already have a similar demo for libindy and Indy Crypto. Now we presented our approach for getting additional error messaging and backtrace for our C libraries and wrappers. And now I would like to report that we almost done our last chunk of this topic-related work. We updated Vcx library also to implement this approach. We have migrated the Vcx on usage failure crate, Rust crate, which crate provides more flexible error handling and also error chaining. And also we have added new API function for getting error details for last occurred error. The Vcx used to return only static error message which corresponded to some specific error code. Sometimes these messages was not really informative, like for example this one, and an only way to get to know what actually went wrong was enabling logging. But now we updated the V6 wrappers for automatic getting error details. And now it's much easier to understand what happened. Now I would like to show how it works in Python wrapper. I will start just one simple test. This test tries to connect, to create a connection which is not ready. Connection isn't initialized yet, and I put a breakpoint on error. Let's check. So we have multiple fields for our object. First two fields we have saved from previous implementation to save backward compatibility. Also, you can see here three additional fields. These fields, first of them, it's full message which actually happened. We can compare the error message we used to have, it's error with connection. It doesn't make sense. And now we see what actually went wrong. We see the connection INV123, its title for connection has an none state, and we can connect to another library from this state. Also, here we see backtrace from SDK library. I scroll to the top, and here we can find a line from in the code which actually throw this exception. I would like to go to this place. It's better to use this one. Let's find connection. I need to check one more time to find row number. This one. Oh, this one. So we see the line of the Vcx code which throws this exception. So for now, I easily can understand and do what I need to fix this error. So I believe that's it. Thank you.
That's really useful, Artem. Thank you. And as we were rolling this out, we had to make a hard decision that changing those error numbers means that applications that upgrade without updating their error handling will move from the pretty generic errors they were getting before to a completely generic error until they update to use the new, more specific error codes. We discussed that with the maintainers when we were submitting the pull request and felt like that was a reasonable trade-off. But if you upgrade, be aware that those error codes changed, and you probably want to handle you need to make sure you handle the new ones. Did I summarize that correctly, Artem?
Yes, I also have one important note. We have updated Java, Python, and Objective-C wrappers for automatically getting error, but we faced with an issue for Node.js wrapper because Node.js has only one thread, and we can't get an Vcx error from new thread which has been spawned. So we created a separate story for this. We need to find another way for getting errors for Node.js wrappers. Also, there is the same problem in libindy.
Excellent. That's an important note. So thank you for that. Very good. So the next topic of conversation is the audit ledger. So Alex, take us through that.
Yeah, thank you. Let me share my screen. Okay, so this sprint we completed the first task in the epic of Audit Ledger. So technically, Audit Ledger is just another ledger, a fourth default ledger that we have. So just to remind you that we have multiple ledgers, pool, domain, config, and now we have the fourth default ones called Audit. So technically, it's the same ledger as any other. It contains transaction log and Merkle tree. The only exception is that it doesn't have any state associated with the ledger. But let me start with describing why we need this ledger and what issues it solves.
And just as a quick note, that diagram is one people keep asking me for. It's in the docs design folder of
it's in docs.
Was that
in docs.
Docs, yeah.
Yeah.
So really useful diagram.
Yes. So if anyone is interested in the technical documentation of Indy Node and Indy Plenum, feel free to go to the docs folder. There are docs folders in both Indy Node and Indy Plenum, and you can find different markdown documents and diagrams. Okay, so this is, by the way, ongoing pull request with update of documentation to mention Audit Ledger in our diagrams. So why do we need Audit Ledger? The first reason is synchronization between ledgers, and the Audit Ledger is an entity which can help us to have a global ordering between different ledgers. Because as of now, I know that we have multiple ledgers, as I mentioned, and transactions are ordered in batches. One batch is created for only one ledger. And as of now, the ledgers are not, they don't have any global ordering. So every ledger has its own local sequence numbers and local ordering. So if you have a look at our ledgers, you cannot see if transaction A from pool ledger is ordered before transaction B from domain ledger. Well, if our transactions were totally independent, that can be fine, but transactions from different ledgers are actually dependent on each other. For example, domain ledger transactions are used for authentication and authorization, checking of roles and signatures. Transactions from pool representing the actual nodes in the system are also used for BLS multi-signature verification during ordering. Transactions from config ledgers can be used for defining how many signatures are required for authorization and what roles are required and so on. And so Audit Ledger can be used to restore this global ordering of batches between and hence transactions between all our ledgers. The second reason is that how we do the catch-up. So just a quick reminder, catch-up is a procedure to get the missing transactions that the pool ordered while the given node was offline or just joined the pool. And since we have multiple ledgers, all ledgers are caught up sequentially, one by one, in the following order: audit, pool, config, and domain. And you know that well, when we do catch up, the pool may still continue ordering, and if it can be turned out that one of the caught up ledgers can be ahead of others, and when the node starts applying transactions next, it can lead to some inconsistent state. So Audit Ledger can fix these issues, making sure that all ledgers are caught up to the same point, to the same three-phase commit batch. The next reason why we need the Audit Ledger, why we can use it, is to recovering of pool state. When a new node joins a pool or it's restarted, it needs to know what is the current state of the pool to be able to join consensus. In particular, it needs to know the current ledger and corresponding states, and it's done as a result of catch-up procedure, but also it needs to know what is the current view, what is the last audit batch, and what are the primaries for each protocol instances. As of now, this information is propagated during a special sub-protocol using the vchange down messages. But with the audit ledger, we can avoid this step and just get all this information from the audit ledger, from the last transaction of audit ledger. And the last reason why we may need audit ledger is external audit. Although we have a reliable BFT consensus protocol, one may want to perform external audit and validation of all the transactions written to the ledger. And because of the reasons I just described in the previous section, if you don't have audit ledger, it's not possible to do this. So the audit ledger can help to restore the ordering of all transactions from different ledgers and check if they're applied correctly. So how this ledger is implemented? As I said, technically this is just a common ledger as any other ones. Currently it has just one transaction type. It's called audit transaction. And here you can see the format of this transaction. So this is a common format. The data is the following. So it has, as I said, the current view node pre-prepare signal. That is, it identifies the 3PC batch associated with this audit ledger transaction. Also, audit ledger has the size of all other ledgers in the pool. And it has information about what is the root of the ledger and state after applying this three-phase commit batch. And the last thing that it has is information about all the primaries. Please note that if the ledger is changed in the 3PC batch, then the root is mentioned explicitly in base 58 encoding. If it isn't changed, then we just use a delta difference between the current audit transaction sequence number and the sequence number of audit transaction where it was changed last time. This is done so just to have a more compact format for audit ledger, so that it requires less storage. Then how audit transaction is ordered. Now to show this, let me see the updates on this diagram. By the way, this is I would say this is a main diagram in Evernym Indy Node, and for anyone who wants to understand it, I recommend to read this diagram. This is a diagram representing how consensus protocol works. And you can see as part of our consensus protocol, a primary creates a new three-phase commit batch, creates a new pre-prepare, and then it applies the three-phase commit batch. And previously, three-phase commit batch produced only transactions for the ledger it was created to, but now it also creates a transaction, one transaction for every batch to audit ledger and applies this on this step. And the resulted root hash of audit ledger, uncommitted root hash, is put into pre-prepare, so that other nodes can also apply this, create and apply this audit transaction and verify that audit ledger root hash is the same as the one on the primary. It is needed to make sure that the audit ledger is consistent. So we have the same checks for any other ledger, and for the audit ledger, we're also making sure that it's consistent and we can trust what is written there. And again, how it's applied, committed to the audit ledger, it's the same as for any other ledger. At the same point when the three-phase commit batch is executed, is committed, we also commit and execute the corresponding audit ledger transaction. So you can see that audit ledger is essentially integrated into our consensus protocol and the process of applying and validation of transactions. So in other words, we can say that for every pre-prepare, transactions are applied to into two ledgers. the main ledger that the batch was created for, and the audit ledger. So as I mentioned, the audit ledger is used for catch-up and for pool state recovery. I'm not going into these details about how exactly it's used there, because it will be this work is in progress and it will be discussed during our next demos next sprint. So let me just briefly show you the tests. So we have a new test for audit ledger. In particular, we check that audit ledger is updated during the freshness checks. So even if you don't have any requests, any transactions being audited, we have freshness checks to update the last freshness time, and each freshness check leads to a new transaction in audit ledger. Also, there are tests to check that audit ledger is properly updated during common ordering into different ledger, different domain, pool, and config ledgers. So we have tests to check the format of audit ledger transaction, and unit tests for audit ledger creator. So that's basically all. And during the next sprint, we're going to continue this work, and I hope that the next demo will provide more information about how exactly audit ledger is used to solve the issues that I just mentioned.
Thanks, Alex. That was really, really useful and informative. It probably won't be ready to release until the end of March, so we're probably going to delay the Indy Node release until the end of the month. Stephen, do you have any questions on the audit ledger? That was a lot of information.
No, that was really good. It's nice to see the audit ledger coming together, since it was just something we came up with not too long ago, and it's exciting to see the great progress.
Excellent, thanks. Let's proceed to the next. So Andrew is going to take us through the auth rules moving to the config ledger, and the audit ledger, we want to make sure we covered all that information for people. So this meeting is probably going to go a little past the half hour, so people who need to drop for another meeting, you can do that, but we'll still take time for Andrew to take us through the auth rules and Renata take us through the view change improvement.
Let me share my screen. During the spring, I was working on integration new auth rules into config state and config ledger. First of all, I want to describe some terms like what is auth map, what is the action ID, and what is the constraint. Auth map helps to build association between what the action user wants to do and who can do this action. In these terms, what the action user wants to do, it's the action ID, and who can do this, it's auth constraint or just constraint. Well, action ID is a key in our auth map, and constraint is the value. In key definition, you can see on this slide, it's a string like this format, where action prefix is one of add or edit string, then text and type, field is field in TXN like role for name or services for no transaction, etc. Then optionally old value will be used for edit action and a new value. For example, if user want to add a name or add a steward, then action will be as first item, and edit. If user want to edit some transactions, then action ID looks like second item. Well, asterisk means that any value is accepted. Value definition. Value is a constraint. For now, we have two types of constraint. Of our constraint, it's role constraint and or and constraint. Role constraint is the simplest case. It's include role, one current possible roles to trust anchor, and network monitor. Then count of signatures. As of now, by default, we use one signature, but in future we can use more than one signature. It needs to be on it. It's a flag like true or false, and some additional metadata. And or constraints, it's a combination of role constraints. So now we can support some kind of combination like or and or and etc. For example, we can can require one steward or one trustee or three stewards for doing this action, or some kind of discrimination. Well, for example, for now we have next pair of action ID and constraint. It's pair for adding a network monitor role. Well, as of now, we can use a constraint from the local static map and from state. In state, well, all the keys into our map are static, and we can modify only constraint, only value by sending our rule to XN. Well, storing into config state, it's just a pair of k value. K is encoded action ID string, which described above, and value is a serialized constraint object. As of now, we can modify constraint by sending our rule to XN. For doing this, we should compile action ID string from TXN. As of now, we assume that we already have this action ID in the static house map. Then we create constraint object from TXN and put TXN into ledger and into state by default way, and put a pair constraint and execute into state. Well, as a result, so now we have the next authorization procedure. For example, if we have some action from users, then we check. Firstly, we can check is action accepted. If it is, then we try to find this action ID in state. If there is some constraint into the state, it means that was sent in as rule to XN. Then we use constraint from strain, or we use default value from local static map. And if constraint accepted, then validation passed. Well, that's all from my side.
That's really useful. We recognize that the largest deployment of Indy is the sovereign network, and they've got a variety of networks between the very conservative main production network to their steward test network, development networks, and individual development environments. And each of these have very different governance policies. So we needed to build something flexible enough that they could meet all those needs and evolve it over time. and I think you did a good job with meeting that goal. So thank you, Andrew. And Renata, you tackled another difficult view change bug. You seem to take them all, so appreciate it. Can you show us the most recent one you fixed?
I will try to say shorter. I hope you can see my screen.
Yep, looks good.
Today we will talk about the storage of instance change messages. In case when a node detects a problem with the primary node, the instance change message is sent. And when a node collecting a quorum of messages, a view change begins. Why it was necessary to change the storage of these messages? Looks at the pool of 4 nodes. The 4th node sends instance change messages to other nodes, and the number of such messages becomes 1 for all storages. Now node 1, node 2, and node 3 restarts. This happens quickly enough to not affect the pool. Since the messages are stored in RAM, after restarts, messages will be lost. There will be no messages on restarted nodes, but on node 4, it will be 1. Then node 2 and node 3 send instance change messages. On the 1st, 2nd, and 3rd nodes, there will be 2 messages. And on the node 4, there will be 3 messages. This is enough to start a view change. And this is bad because node 4 stops working, being in a permanent view change, and even after a view change on all nodes, cannot begin to order at all. By repeating such actions, we can break more than F nodes, pull will stop at transactions ordering. This problem can be solved by storing instance change messages in the database instead of RAM. After restarting a node, messages will not be lost, and the view change will begin on all nodes. As a result, it will be successfully completed. What are the changes in the code? The class instance change provider has been created, and it contains node status database. This is the key value storage in RocksDB, and database cache. When the node is started, all instance change messages are moved from database to a cache. When adding or deleting messages, it is changed in the cache and database. And cache needed to speed up work with the database. Otherwise, deserialization of the database data will happen for every query to instance change storage. In this format, store data in the database. So now section instance change queue will look in the validation info in the following format. If any scripts are based on the old format, you will need to update them. And this is the instance change provider class, class for working with cache, and public methods to change and query some data about instance changes.
I'm not sure that Slava can join us because, well, actually he's not on the project anymore, but yeah, I pinged him, but I don't know.
It's good. For this task with instance changes, we had tests, and upon completion of the task, it was successfully tested. That's all for my part. Thank you. Questions?
Thank you. That was really useful. And anybody who is interested in the details about view change, you really should look in the Evernym YouTube channel at our Hyperledger Indy playlist. And you'll see Renata's done a number of these where she's taken people through step-by-step how view change works. It's a fairly complicated part of how Indy Node functions, and you can really understand the details by going through that list. So thank you again, Renata, for that. And we'll finish up now. Next sprint on Indy Node, we're going to finish Audit Ledger and, well, get close to finishing it and continue and get close to finishing the multi-signature stuff. It'll probably take 2 sprints to get it all the way done and released. So we want that out by the end of March is the goal. Indy SDK is a bit harder to figure out because our main goal for the next sprint is to document our proposal for an Indy SDK 2.0 architecture and give feedback on that proposal. And so we don't know what additional work we're going to do because we need to give feedback and respond to that. There are a few, we've been really grateful for people who have contributed some raised bugs by the community, and there's a number of pull requests that we need to review. And there was some security audits that had some results we're going to go through. So we'll do some other work as well, but the main goal is going to be figuring out that architecture that will allow us to migrate the current Indy SDK to a new format that supports the message families necessary for agent-to-agent communication interoperability among all the agents in the ecosystem, the Evernym agents and all the other ones we listed at the beginning of the call. So that's our goal. Let us know if you have any questions. We're always hanging out at chat.hyperledger.org. That's a Rocket Chat instance. Chat.hyperledger.org in the Indy or Indy Node or Indy SDK channels. You can reach us there. And look forward to talking to people as they have questions. Reach out to us online. So thank you very much.